Hey, what's up everybody? I'd like to welcome you to another audio programmer tutorial. And in today's tutorial, we're going to learn how to use JUCE's SmoothValue class to ensure smooth, click-free changes when moving parameters quickly. So this is what we had from our last tutorial. So as you can hear, there are some discontinuities and crackling and what some people call a zipper noise that's happening when I change the frequency of the sine wave. Here is what it should sound like once we're done with this tutorial. The crackling is now gone and you can hear a smooth change when I'm moving the frequency slider. And if you're curious on how to build your own audio products and plugins, be sure to check out our community, books, and services. You can find all of these on our website, theaudioprogrammer.com. And I'll also put a link to the code in the video description below. Also, if you find this tutorial to be helpful, be sure to like and subscribe. It's a big help. And with that being said, let's get started. All right, so here we are in the JUCE documentation for SmoothValue. And before we jump in, I just wanted to talk a little bit about why we're actually using this. So the main reason that we're using this is because, as you were hearing in our demonstration before, when we were moving the frequency slider around, we were getting those clicks. And that's because the change that's happening between one frequency and when I move the slider to the next frequency is instant. And so the sine wave doesn't actually have any time to change between those two frequencies. And because of that, we're getting a discontinuity. These smooth values allow us to give a little bit of time to actually interpolate between the frequency that we were at and the frequency that we moved the slider to. So what it does is it smooths that value out over time so that the change is not so sudden. We can make it where it's basically imperceivable to the person who's using the frequency slider, or we can make that change even longer over time where it's very gradual. And I'll give you a demonstration of what those look like. So going back to the JUCE documentation here, we have the class called SmoothValue. Now, if you've worked with JUCE before, you may be familiar with an older class called LinearSmoothedValue, and these are actually the same under the hood. The main difference that you have with SmoothValue, which is slightly newer, is that you can choose between what type of smoothing that you're doing. So if you look down a little bit further below, what you can see is that the way this works is that you declare a SmoothValue object. Then you have the type of data that you're working with, which in this case is going to be float data. And then you can choose between a smoothing type called linear, which smooths the value linearly, or you have this other option, which is called multiplicative, which smooths it on more of a logarithmic scale, which is more in line with how we hear sound. So the difference between these two is not very much as a non-DSP engineer, but for somebody with an experienced ear, you would be able to hear the difference between those. All right, here we are in the code now, and I am in my sine wave header file. This is where we're going to implement our SmoothValue object. As I was saying before, if you're experienced with JUCE, then you may be familiar with this, which is JUCE LinearSmoothedValue. Then you declare a value type, which in this case, we're dealing with floating point numbers. That's why we're doing float there. And I'll just call this x1 for example 1. The way that we would do this if we were doing it using SmoothValue is that we have two arguments here. One is the type of data that we're dealing with, which once again is float. And then the second argument is optional because we see that the smoothing type, and we have this equals sign here, and it equals JUCE value smoothing types linear. So that means that our default smoothing value type is linear. So what we could do is we could leave it like this. And these two lines of code, 31 and 32, are essentially saying the same thing. Now, as I was saying before, we have this extra option with the smoothing value object where we could say JUCE value smoothing types and then do multiplicative smoothing. And now that gives you a different type of smoothing than this first example. So as I was saying before, two ways of saying essentially the same thing, but if you want that extra option of doing multiplicative smoothing, which is better for things like frequency, then that's the way that you would declare that. Now let's go ahead and change this class member to something that's a little bit more indicative of what we're trying to do, which is smoothing the frequency. So I'm calling this smoothed freak. And now let's figure out how we're going to implement this into our class. The first thing that we need to do is define how long we want it to take to ramp between the previous value and the new value. For intuition, I'm going to start this off with 1 second. So when the user moves their slider from one frequency to another, then we want it to take 1 second to get from the old value to the new value. The way you can do this is by using the reset method, and we have two options here. One is to supply the sample rate and the ramp length in seconds. So in this case, if it was 1 second, it would just be 1 there. Another way that we could do this is by providing a number of steps in samples. And so if we wanted that to be the way that we do this, then we would just pass in the sample rate directly in here, and it would take maybe 44,100 or 48,000 steps to get from the old value to the new value. I personally find this first way to be a little bit more intuitive, and that's what we're going to use. So what we'll do is we want to put this in the prepare method. We don't need to put this in the process method where this is calling again and again every audio callback, right? So we only need to set this once. So we will say smooth frequency dot reset. The first argument is the sample rate, and then the second argument is how long we want that ramp to take, which we will make 1 second just to start off. Another thing that is essential for us to do in this prepare method that, in my opinion, is not very well documented is we need to set what we want the current frequency to be. So that is the starting frequency. So we have to give it kind of a default value. And the way that we can do this is by calling smooth frequency set current and target value. So this is something that a lot of people, including myself, miss quite often, and then things don't work properly. So this is a way of initializing it to a value. So what I could do is set current and target value, and then what I'm going to do is just get whatever the first frequency that we pass in, just get that and pass that in. So that is essentially like an initialization step to give our smooth frequency its value so that the sine wave can start playing. Now what we want to do is we're going to go back to our sine wave header file, and then we want to look at the place where we're setting the frequency. So currently what we're doing is we're passing in whatever the new frequency is, and then we're passing that on to a class member called frequency, and then going back over to our process block in sine wave, then we're passing that frequency in, and that's what's computing our sine wave. We're going to change that a little bit here. The first thing that we want to do is adapt this function set frequency. Currently, the new frequency that we get in from the slider is setting that to our class member frequency, which is getting put as an instantaneous change to our frequency when we're computing our sine wave. And what we needed to do is instead get placed into this smooth frequency so that it can build this ramp between the old frequency and the new frequency. And the way that we do this is we just change this to say now smooth frequency set target value, and then we're going to put the new frequency as the target value. So what that means is that when the user changes their slider from 220 hertz to, let's say, 500 hertz, 500 is going to be the new frequency, and that's going to be the target value that's going to be set for the smooth within smooth frequency. Now it's going to take 1 second to get from 220 to 500 because 500 is our new destination. Okay, so the second thing that we can do is we can now get rid of this frequency class member, and then in here you can see that there's a little complaint here that it doesn't know what frequency is anymore. And now what we can do is we can say float frequency, so we can make this local now, And here we can say smooth frequency get next value. So get next value is the way that we're going to get all those little points between our two endpoints. So on one side we have the previous slider position. So as we were saying in our example before, 220. And then we have the new slider position, 500. And there are going to be a lot of little points in between 220 and 500, right? And get next value is getting all of those little values of that ramp time that is happening in between those two endpoints. And so that's why we're taking this get next value, we're assigning it to frequency, and then we're inputting that into the sine wave equation. So it's going to take 1 second to get all of those values in between 220 and 500. If we wanted that to be faster, then we would just change our ramp time up here in prepare. So going back to our header file, we're nearly ready to build now. One other thing that we need to do is that we see that since we got rid of the frequency class member, that we need to now change this get frequency member. Okay, so this should be smooth freq and then get next value. Right. Now we're getting a complaint here that the problem here is that we've made this function const and that smooth freq.getNextValue is going to return a non-const float. So we need to get rid of this const qualifier for get frequency, and that should fix our problem. All right, so now we're going to go ahead and build this. I'm going to give you a little spoiler alert here, which is that our problem is not going to be completely fixed. There's actually something else unrelated to SmoothValue that's going to cause discontinuities. But what I want you to listen for this time around is just the change. You should hear a 1 second ramp time between the previous value of what the slider is and the new place that I moved the slider. Okay, and then once we do that, then I'm going to explain what's happening with those discontinuities and how we're going to fix those. So here we go. All right, so hopefully what you heard there was that there's a 1 second delay or 1 second ramp that's happening between the old value and the new value. And as you heard, there's still some discontinuities. That's actually related to the way that I'm computing this sine wave here in the process block. And I'm going to show you what changes we need to make in order to fix that right now. So one thing that I'll say before I go into this is that if you came for this video simply to learn how to use smooth values, then you're good to go here. But if you want to learn why this sine wave is not functioning quite properly, then please feel free to keep viewing. So the reason that this isn't working properly is because currently our sine wave is wrapping between 0 and 1. And I thought that this would be a good way of keeping it simple for time increments without bringing pi too far into our workflow. And that works fine if our frequency is a whole number. But if our frequency is fractional, then what happens is that we're going to get a little click that's going to happen from a discontinuity that happens every second. So I'll show you what I mean. When I build, you're going to hear that there is a smooth frequency because it's a whole number, right? So let's go ahead and build. So we hear that that is fine. That's a nice smooth frequency, but watch what happens if I turn it to a fractional frequency. Every second we're getting that little click that's happening, and that's because we have this fractional frequency and that it's not wrapping properly. What we need to do is change this wrapping to happen at 2 pi rather than at 1.0. We also need to make a couple other changes here. So first thing that we're going to do is we're going to change these 1.0 for our time increments over to our member variable double pi, which is 2 times pi. So we'll make this double pi. And we'll make this double pi. And rather than making this current time, what we're going to do is just change this to be current phase. So we're just going to change the name of this. What I'm going to do is I'm going to rename this. I'll call this phases rather than current time. And now that makes a little bit more sense because we're talking about phase rather than time. Another thing that we need to do is we need to change what our time increment is. So rather than 1 over the sample rate, we're going to change this and take this out of prepare because we're going to need to use our frequency to help calculate what our phase increment is going to be. And so we're going to create a new local variable here. We could just call this const float, and then this will be phase inc, meaning phase increment, and that's going to equal double pi times the frequency, and then we're going to divide all of that by the sample rate. So we're essentially changing this from a function of time to a function of phase. And now rather than using time increment to increment the phase, we're going to use phase increment. And now that we've done all of this, what we can do is simplify our sine equation and just take the sine of the current phase. So we can take this double pi times frequency times phases. We'll just take this out. So that becomes our sine equation now. And we can also take away this time increment up here because we aren't using time increment anymore. And we can go over here, just delete time increment as a class member. And we should be good to test this out. Let's go ahead and try it out. Great. So now we're getting smooth changes. And we can hear that those changes are happening over 1 second because they take 1 second to get from our previous point to our new destination. So one way that we can improve this is by making this a little bit more intuitive. So going to our reset function for our smooth frequency, let's change this to something like 0.05. So that's 50 milliseconds, and that'll make the change a little bit more instantaneous so the user won't be able to perceive it. But now we hear that the changes are very smooth. We're not getting any more of those artifacts or discontinuities. Okay. A few more little things that we could do to improve this is that we can change where this phases channel. We can just abstract this out a little bit because this looks a little bit messy to me. So what I can do is I can say auto, and we can make this a reference, and we'll call this phase. We'll make that equal to phases and the channel. Now we just simplify this down. We can see that that makes it nice and neat. Great. We see that it's also complaining there that it's taking it from, because we're putting in an int here. And I think that if we static cast this to a size t, we should be good there. So great. So that makes that fine. And then same thing here. So we're comparing buffer get number of channels, which is an int, phases.size, which is a size t. So we could probably, if we really wanted to get into the weeds here, we can do this. That should fix that. And then we got number of channels, same sort of thing. We want to static cast that to a size t. So scrolling down, we shouldn't have any more warnings. Okay, we got this frequency here, and that can be made const. So great. So now let's just check it one more time. Perfect. Everything is working as designed. All right, so things got a little bit challenging there because we had two problems to solve. The smoothing of the parameter changes and figuring out a better way to compute our sine wave. But I'm glad that you hung out with me to this point. If you found this helpful, be sure to give it a like and subscribe. And I hope to see you next time. Happy coding until then. See ya.